Alright, so here is the million-dollar question. Why is that PV negative? We use a negative number to indicate when money is going away from us. So money isn't really going away from you, right? Because you're just investing that. But for the time being, you're taking that $500, investing it, and the money comes back to us in a positive amount. So keep that in mind. Just think about it. Is money going away from us, or is money coming to us? So initially, we are investing $500, so it's going away from us. It's coming back as the future value. This example 2 is exactly the same one as we did in the 1.3 videos, but I just want to show you that these two things, these two methods, are the same. We can use it algebraically, we can use our sweet algebraic skills, or we can use the TVM Solver, and they will give us the exact same amount. If you wanted to check it out, why don't you sit with your 3.1 notes, and you can compare, and you can see that the questions are exactly the same. So, Sabrine is 20 years old. She has inherited some money from a relative. Sabrine wants to invest some of the money so she can buy a home in Coaldale, Alberta when she turns 33. Remember, she's got goals. She estimates that she will need $210,000 to buy a home. How much does she have to invest now at 7.5% compounded annually? What is the rate of return on her investment? What would the rate of how would the rate of return change if she had an interest rate? If her interest rate decreased to 6.5%, but it was compounded quarterly. So again, this should look exactly the same, and let's go through it. So in part A. Let's fill in the needed information. We know that it's compounded annually. Okay, so I'm just going to put my 1 here and my 1 here already. My n value here is going to be the number of compounding periods, 1, times the number of years that she needs to invest. 33 minus 20 is 32. I%, we know that it's going to be 7.5, so we're literally going to type in 7.5. The present value, we don't know what that is because it says how much does she need to invest now. So I'm going to put a little dot there. That means that that's what we're going to solve for. Payment is 0 because we're just making a single investment. Again, this will come up, the PMT will come up in the next lesson. And we know that the future value must be $210,000. Now the PV is going to come back as negative, but do not be alarmed. Remember, it's money that she needs to invest initially. So let's call up our TVM Solver. Oh, hi. Let's put in the necessary information. So 1 times 13. I'm kind of putting that in just to show you that this is what happens. Enter. Ba-da-da. Our interest rate is 7.5. Our PV, we don't know what it is, so we're just going to keep it at negative 500. We're going to come back and solve for it. We're going to keep our PMT at 0, and our future value is $210,000. Our payments per year is 1, enter, and you'll notice that it automatically shifts to the same thing. We might come across where the payments per year and compounding periods per year are different. But we'll cross that bridge when we get to it. And now I want to go up to PV. To solve for it, we go alpha, solve, and we're noticing that we're going to get negative 82,018.02. Now this is precisely the same as what we had before. How incredible is that? So since we solve for it, we indicate it with a little dot, and I can write a little statement that the PV is 82,1802. Okay, just so that you can indicate that we know that the present value must be $82,018.02. So let's calculate that rate of return. We know that the rate of return equals interest over principal. I'm going to show you a really cool way to calculate the interest here. Now you want to go into the finance options again, and you're going to look for something that looks like this. This and then int, and then open bracket. This is the sum of the interest. And what's cool about this is we put in our first payment or compounding period, and then we end with our last one, so 13. What's cool about this is you can start like the 5th payment into the end, or you can start at the beginning and see how what the interest is halfway through. But for this example here, we're going to do sum int 1, 3, saying what's the interest from the first compounding period to the last compounding period. The way we find this, I'm just going to quit this for right now. I'm going to go to, you guys are going to go to app, okay? Or you might have to go to this finance option here, and I'm just going to scroll down. And here, sum int, like that, and hit enter. I put 1, so the beginning compounding period, and then 13 to the last one. Hit enter. That's what my interest is. Look back on your 1.3 notes. It's the exact same. How cool is that? Okay. So we're going to say that this is what the interest is. I mean, another way that you could do it is you could just do the 210,000 minus the 82,1802. That's absolutely fine, but I'm just showing you the TVM Solver way. If you prefer to calculate the interest in that way, in the previous way, algebraically, that is absolutely fine. It comes out to the exact same anyway. So we're going to do 12,790. Oh, sorry, my bad. It's not 12,000 at all. Let me just change that. 127,981.98. All over the principal, the present value, or what you need to invest first, 82,018.02. And we get a rate of return that's 1.560. Exactly the same as before. See how much quicker that was? Let's find, and we're especially going to notice it in that C part, because for the C part and the other one, we had to calculate everything by hand. But now, literally, we're just going to change a few pieces of information in our TVM Solver. We know that the interest rate changes and the compound quarterly changes. And we know our N is going to be changing too. So, our N is the number of compounding periods per year, which is 4, times the number of years, 13. Saying the interest rate is now 6.5%. You still want to solve for that present value. Payment stays 0. Our future value is 210,000. And we know that our PY and CY are both 4. So let's plug that into our calculator. Remember how to get that. You will probably go apps and then finance. I'm going to just go to my finance, my TVM Solver. I'm going to type in the necessary things. So 4 times 13, 6.5. I'm going to skip over the PMT because that's what, the PV because that's what we're solving for. PMT stays 0. FV, future value, stays 210,000. And payments per year goes to 4. And it'll automatically change for the compounding period per year. So I'm going to go all the way up to PV again. Go alpha, enter, and I get $90,821.83, which again is the exact present value that we discovered the first time we saw this question. Remember, it's negative because it initially goes away from us so that we can invest it. So rate of return is interest over principal. We're going to go sum int, but instead of going to 13, we're going to go 1 to 53. Now just to be clear about this, the interest function uses what is currently in the TVM solver. So if we wanted to go back and find the interest for the previous question, we would have to put all the information again in our TVM solver. But because we want to find the sum of the interest of this specific one, we're okay. So we want to go, and we want to go to our finance. You guys will go apps, finance, and I'm going to scroll down to our sum int. And I'm going to go 1, comma, 52, enter. Look at that, $119,178.17, which is exactly what it was before. So we say that our interest is 119,178 over the principal, or the present value, 90812.83, and we get a rate of return of 1.312, which is exactly the same as we found before.